Alright chemists, so let's start with a bit of gravimetric analysis. So let's just summarise how it's done and we'll do a quick calculation just to show you the sort of things you do. So, 2 words, analyte, that is the substance whose chemical composition is being measured or identified, and that can even include the smaller parts of the overall sample, so the components of the sample. Alright, gravimetric analysis, that's when we measure out the different components of a mixture in percentages. So that's simple. So let's go through how we would do one. So if we've got a mixture of sand and salt, first you measure the mass of the overall sample, and that's 3.45 grams. Okay, so you mix it with water to dissolve the sodium chloride. Okay, the sand's not going to dissolve. So we filter and weigh the dried residue, subtract from that the mass of the filter paper. We probably should have measured the mass of the filter paper. Then we would weigh the evaporating basin beforehand, evaporate the H2O away from the filtrate, and that should leave us with the mass. So then we weigh the mass of the sodium chloride, and this is important. We would then subtract or minus the mass of the evaporating basin from that to give us just the mass of the salt. Okay, so let's run through the quick calculations. These are really simple, but they sound more confusing than they are. So it's pretty much the mass of the analyte in the sample is equal to the mass of the analyte minus the mass of the sample times 100. Okay, so the mass of the sample we have 3.45, mass of the sand we have 1.27, and mass of the sodium chloride is 2.08 grams. Alright, just a quick note here. That's 3 significant figures. Now, if you have a look over here, just skipping ahead, our percentages are all written to 3 significant figures. It's appropriate that you write down your percentages to whatever the number of decimal places that it is, so it's the same as the number of significant figures you have. That's the way to do it. It just reflects the accuracy of your measurements. Anyway, so to work out the mass of the sand is really simple. We divide the mass of the sand by the mass of the sample times by 100. That comes out here to be about 36.8%. Alright, so the mass, these come from one of your experiments in class, by the way. So here we go, mass of sodium chloride divided by the mass of the sample gives us 60.3%. Now, these add up to 97.1%. Okay, so it's not a full 100%. There's 2 reasons this could be. Actually there's 3. One of the students might have dropped the entire sample on the ground and then picked it up and just carried on from there. Or, more realistically, because that student clearly would have started again, you could just have some experimental error. Like when you're evaporating off, you might lose some, you might have measured this one incorrectly or this one incorrectly, just experimental error. Somewhere in there you've made a mistake. Also, it's likely that there's some other component in there that was unidentified, and it might have boiled off with the water. It might have, who knows? Like there might have been another sample in there that's unidentified. So that's what we've got. That's how to do it. I hope that's pretty simple. It really is. Make sure you're measuring just the masses. You're taking away the masses of any equipment you're using, like filter paper or evaporating basins, and it's just whatever the component is divided by the entire sample times by 100. That's all it is. Alright, see you later.